stuff we heard yesterday. I'm just wondering, I couldn't fall asleep last night thinking about what we're actually doing as roasters is we're trying to keep a seed that's trying to become a plant and just keeping it in that belief for a long time, and then we roast it. We just put it down at 200 degrees. That's brutal force, isn't it? Anyway, welcome this morning, everyone. We should be starting with the first lecture. He's a product manager of one of the biggest grinding manufacturing groups, the Emerald Group, which includes Marconic Ditting and Anfim Roasters. One more? Did I say roasters? I'm sorry. Grinders, yes. So he stands in the middle of the R&D and communication to customers and documentations of all machines that they manufacture. And please say welcome to Christian Klaps. Good morning. So the way we're going to run this is Christian is going to do a short 20 minutes presentation on some of the latest finding in particle size repartition, and then we'll have a group discussion on grinders for another 20 minutes. Welcome, Christian.
Thank you. And a cupping afterwards, so that's going to be interesting. Well, good morning, everyone. I hope you had some good breakfast. And I'm going to jump right into it. I'm going to talk a little bit about what we found in the last years in some tests and some studies we did with different people, and then I kind of want to finish in what could be the next steps. What are we experiencing? Which obstacles are we experiencing in testing, in developing, in finding new ways of grinding or finding new accuracies of grinding, so to say. And I think I really want to keep it short, just some basic information, and then I think it's always more interesting to talk with you about your experience, your questions, and then we can talk about what is really interesting to you. Sorry. So last night I was asking some people, where do I start? Do I start with strength and extraction, and everybody knows the brew chart and the refractometer? Does anybody not know about that? Okay, great. Yeah, Jens said we should send them home otherwise, but because then they're in the wrong place. But okay, I just want to quickly go through that. Of course, strength versus extraction. We're dialing in coffees with all these different parameters, and grinding, of course, altogether is one very important part of that. And so in the end, we get a coffee in the cup which we can measure now, and we get it to a certain strength, TDS, which really, as we know in the brew chart, represents something like a subjective preference, so it's different from country to country, from coffee drinker to coffee drinker. But extraction was always defined as something that has to be the same everywhere in the world, between 18 and 22%. So we'll see along the way that this might not be that a strict law anymore. So up to now, the rules were 18 to 22%, because the general understanding was that if you go above 22% extraction rate, you will have a overdeveloped coffee, you will have over-extraction, you will have the roast flavors from the coffee, you will have the bitter flavors, you will have also channeling in espresso if you try to run more and more water, or if you try to grind finer and finer, water will find its way. Now talking about espresso really only. And there was discussion if there might be another sweet spot somewhere below 18%, so I think it was around 16% extraction with a way higher strength. But normally, back in the days, it was said that you have an acidic, sour coffee, underdeveloped coffee, and of course a weak coffee if you stay below 18%. And all these boundaries are broken more and more as we use refractometers, as we use more and more technology to find out and to actually know and measure where we are in the cup. Before 4 or 5 years, before that time, we only used our tongue, and we could only guess. Let's go on. I think I want to please. All right. So it was found out that with high extractions, through the grinding, you can have a more clean cup and more intensive flavors and more sweetness. And that, if you grind and brew and you don't measure, you don't really know where that's coming from. So it's really all down to that you have measured it and that we know where we are. High extractions, if we push extractions higher than 24, 23, 24%, we also realize that we might highlight, or we will definitely highlight, actually, all mistakes that we did in the process chain before that. So if there's been mistakes in fermentation or in storage, in transport, then this is more likely to come out at higher extractions. If we keep the extraction lower, we might keep it under the surface, so to say, and not really highlight it, but it will definitely come out if we extract higher. Past crop, as I said, transport, green coffee defects, the whole process chain needs to be really completely perfect in order to get a good tasting coffee with higher extractions. We tested lots of different coffees and we tried different defects, tried different extractions as well, and below 22%, below 20%, we managed to keep these defects hidden in the coffee, but really if you go higher, they all come out. So for espresso, I guess if you all know, it's to get to these high extractions is not really only using a different grinder. It really takes many more parameters to get to that great coffee above 22, 23%. You have to really make sure that all the points are taken care of. So the whole focus nowadays is not really only the roasted coffee into a specific grinder and how you grind it fine coarse, and then into a cup on extraction. Last night I was talking about the definition of espresso before 3, 4, 5 years before we started measuring everything, and it was put in 14 grams, well the Italian definition, 14 grams, 25 seconds, 40 to 50 mils. That's it, so that was the definition. And so how do we define espresso today? Is it a beverage of 10% and everything else is up to you? So just because we can measure means that we have to look into different brewing or preparation parameters, and it's very important that with this, if you want to extract high, the roaster suddenly gets into the equation of the barista. Because if the coffee is not right, we can't get this high extraction. We need a specific coffee, not really only the coffee, but we need a specific roast for that. For filter, it's the same points, but the temping actually. So everything, the whole brewing process, in order to achieve these high extractions with preferable taste, you really have to be more clean, you have to be more accurate in everything what you do in the bar. So a little bit on the EK43. The grinder, to take the mist away from that grinder, is actually, we developed it in the 80s and we started selling it in the 90s as a shop grinder, retail grinder for grinding coffee from the bag into the bag. So it has a big hopper and a bag holder spout. That's what it's actually built for. And it was running well. It was one of our shop grinders, but nothing special. So actually in 2012 it was kind of rediscovered because it can do something different, which really, to be honest, we didn't develop it for. So that's really, somebody found it out just because the measurements were there, just because we could actually go deeper into what's happening there. So in 2011, 2012, at the Brewers' Cups, everybody was sieving out the fines because it became general knowledge that fines are over-extracting and fines are actually in the way of developing a more clean, more like high extraction, yes, but we maybe didn't really know, but a more clean taste. And then just really by chance, this grinder was used, and we found out that you don't really have to sieve out too many fines. So strange. So let's investigate this grinder further, and then this hype started because it was used at barista competitions and mainly the Brewers' Cup as well. So technology-wise, development-wise, it's really the main difference between this grinder and probably many or all other grinders is that we have vertical grinding discs, and they're made from cast steel, not tool steel. So they come out of the form, out of a tool. The main teeth from the inside to the outside, they are not machined, so they're actually quite round and bumpy, so it's a cast surface. Only the final teeth in the very end, they are machined, they are ground on the machines in our factory. So that's quite a different design approach, quite a different teeth design approach, which we have in a couple of other grinders as well. But in other grinders, also this technology, also this cast steel, doesn't produce the same grind quality as in the EK43. So we tested all grinders that are on the market, ours and others. So this grinder really does something special there. And also, due to the vertical position of the grinding discs, it gives you a completely different grind chamber and kind of bean going through approach than all other espresso grinders, or all other grind-on-demand espresso grinders, because they are always full of coffee. Grind-on-demand nowadays is grind by time. So we start and stop the motor within 4.05 seconds, for example, and the coffee that comes out is your dose. And you can't really adjust the weight, you have to adjust the time. And for that, the grinder, the whole system, the grind chamber needs to be full of coffee and always have the same density, so to say, same pressure of coffee from above. So there will always be coffee, there will be residues in the grind chamber running all around all the time. So the difference with the EK43 that it's always empty. Because you only grind what you need, and you actually have to pre-dose because it's not a grind-on-demand grinder. So the aim now for us, and I guess everybody's striving for, is to transfer this into other grinders, or to transfer this into a system that can be used in a bar more efficiently without actually weighing the coffee before. So that's the main point now. But going back into what the EK43 actually really does. So we did lots of tests and studies and measurements and